In our previous lesson, we were talking about the special circumstances when you have either one solution, no solutions, or an infinite number of solutions when you're looking at a system of equations. And so in this particular case that we did yesterday, when we solved this system, we came up with a very specific solution to this system. And it's right here. 2 comma -6. So x is 2 and y is -6. And that is the only ordered pair combination in that order that will work for this system of equations right there. 2x minus y equals 10 and -x plus y equals -8. So we solved it. There's one solution. Checked our answers. Everybody's happy. We're good. Now, the next question on down the page, we were, when we solved this one on using our keen algebra skills in solving systems using, we used substitution where we calculated what y is in terms of x, and then we substituted that into the other equation. And we found that there was no solution because when we got to here, 4 equals -6, and that is not true. And so when you have a system of equations and you come up with something glaringly, obviously not true, it's a false statement, not true, otherwise known as false, there is no solution. That means that those lines never would intersect on a graph. And we graphed that equation on Desmos. And what we found was that on that graph, we had one line like this and another line like that. They had the exact same slope. They crossed the y-axis at different places. But because they had no slope, they had no, because they never intersected, they had no intersection. They had no solution. Okay, now give me just a second here. That is not what I intended to do. All right, so obviously no solution, parallel lines, they never intersect. And then we went to the next one, and the next equation that we, next system of equations that we solved, when it was all said and done, we ended up with, here we had 18 equals 18, which of course is true, absolutely true. And when we have that situation, that means that there are many, many solutions, an infinite number of solutions, as long as whatever number you put in for y, it comes up with a corresponding x value to have a nice xy pair. And we came up with a few of those here. If y was 1, then x would be 4. If y was 2, then x would be 2. If y was 3, well, let's see, that would be, if y was 3, that would be 2 times 3, which is 6. And 6 minus 6 is 0. So if y is 3, come on now, if y was 3, then x would be 0. All right. So as long as that xy pair fits into the scenario here, then you're going to have an unlimited number of those solutions, but they all must lie on that line. Okay. So let's, so we've got, obviously looking at this. And remember when we graphed this one, when this one was graphed, basically what we had was one line, and then the other one was just another line right on top of that line. And when that happens, you're saying, oh, it's the exact same line. Every series of points along that line is a solution. That's why you would have an infinite number of solutions. Okay, so now our review is over from the previous lesson. Let's, and we already did number 5, because this says solve the same system from question 4 using either substitution or linear combination. We did that. And we talked about what ordered pairs make sense, right? We gave 3 ordered pairs here, 4, 1, 2, 2, and 0, 3. We've already done number 5 without even knowing it. Look at that. That's how good we are. So moving on down then to number 6. Number 6 says that the table shows solutions to 3 different systems of equations. Use the given choices to match each solution with the correct interpretation. Okay, so if we end up with a false equation, something like 2 equals negative 5, you should remember that that would be no solution, because when there's a false statement, a false equation, there is no solution. Now, of course, moving on from that, if there is a true equation like 30 equals 30, and 30 does equal 30, that makes it a true equation, then that means that we have many solutions, an infinite number of them, as long as they all lie on that line. And of course, when there is an intersection of points, like in this case, 4 comma 2, x equals 4, y equals 2, there's one value, one and only one value for each variable, then you have a one unique solution, one and only one solution. All right. You just have to remember those rules. All right. If it comes up that one number is equal to some other number, obviously that's false, no solution. If it works out and you don't have any variables, but you end up with a number equaling itself, that of course is true. It means you'll have many infinite solutions. But of course, when you have that single XY pair, you have a unique solution, because that's when those two lines intersect in one spot. All right. So what we have now, we have 3 different systems of equations that we're going to work through and solve. So let's take a look. We have 2x plus 3y equals 3 and negative 4x minus 6y equals 30. All right. Now, we're going to have to manipulate the system, and we need to come up with a plan. What can we multiply by in either one of these equations so that we can eliminate one of the variables? And I think I'm going to eliminate the y so I can solve for x. And so my plan bar there, my plan is to multiply everything in the first equation by 2. And so when I do that, I will have, let's see, 2x times 2 is 4x. 3y times 2 is positive 6y. And 3 times 2 is 6. Okay, there we go. Now, I don't have to do anything to the bottom one. Negative 4x minus 6y equals 30, because I decided I wanted to eliminate my y's. So when I do that, when I combine these, 6y and negative 6y cancel each other out. So I get 0, right? 4x and negative 4x. What? 4x and negative 4x, well, they cancel each other out and they make 0. So 0 plus 0 equals, and let's see, 6 plus 30 is 36. So I get 0 equaling 36. Huh. Well, that's very interesting. I know I did everything right, but 0 equaling 36, 0 does not equal 36. That is a false statement, false equation. So remember what false equation means. I have no solution to this system of equations because I ended up with a false statement. Okay, well, let's go on to number 8 then, shall we? And let's see, determine the solution to this system. All right. Well, let's see. How can I get rid of something? You know what? Just for kicks, I think I'm going to multiply the bottom equation by -1. Now, because when I do that, of course, the top equation stays the same. 3y minus 2x equals 6. And then when I multiply the bottom equation, I get -y, because it's times -1. -2x times -1 is positive 2x. And that's going to equal -6 times -1 is 6. Okay. So now when I do this, I'll eliminate my 2x's. I'll eliminate my x variable because those cancel each other out. Now 3y minus y is 2y. And 6 plus 6 is 12. All right, divide by 2, divide by 2, and I get y equals 12 divided by 2, which is 6. All right, so I know that y is 6. Now, that being the case, I can take that in and substitute it into the other equation. So I'm going to use this one right here. If y is 6, then this becomes 6 minus 2x equals -6. Subtract 6, and I get -2x equals -12. Now I divide by -2, divide by -2. Those cancel out, and x equals -12 divided by -2 is +6. So I've got x equals 6 and y equals 6. So I have one solution here, and that one solution, I'll write it over here, I guess, because it's the only spot I have room for, is 6, 6. Okay, well, we are very, very close to the end of this. But you know what? I'm going to give you guys a break. I'm not going to assign any homework over a 3-day weekend. So